You know, we all use GPS, right? To find the closest coffee shop or to not get lost on a road trip. But what happens when you're navigating a billion-dollar drill ship and being off by just a few centimeters could spell absolute disaster? Well, in these high-stakes marine environments, precision is literally everything. And as we're about to see, the tiniest little installation mistakes can have enormous, and I mean enormous, consequences.
Okay, let's just jump right in. Take a look at this picture. See that little antenna? It's buried deep inside that mess of steel. So, could something that small really cripple a billion-dollar operation? The answer is 100% yes. In fact, a poorly placed antenna just like this one is the single biggest cause of positioning failures out at sea. The real question is, how? Let's break it down.
To really get our heads around the problem, first we've got to understand the technology that demands this kind of perfection. It all starts with a system that takes regular satellite navigation and cranks it up to a whole new level. What we're talking about here is DGNSS. That stands for Differential Global Navigation Satellite Systems. It's basically a way to supercharge standard GPS. It uses ground-based reference stations to correct for tiny errors, boosting accuracy from meters all the way down to just centimeters.
Yeah, the best way to think about it is just GPS on steroids. This is not for finding your way to the grocery store. Nope, this is for keeping a gigantic vessel perfectly still while it's drilling miles below the seabed, or for laying subsea cables with pinpoint accuracy.
So, as you can imagine, when a system this critical gets installed the wrong way, the consequences aren't just some small inconvenience. They can be catastrophic.
I mean, a bad install can lead to a total loss of position. And what does that mean? Well, it means serious safety risks for everyone on board. It means incredibly expensive vessel downtime. It means failing to meet strict operational rules. And it can even mean having to go back and redo incredibly costly survey work from scratch. The stakes just could not be higher. So, how does this failure actually happen? Well, the first major villain in our story is something surprisingly simple: physical blockages. It really is a battle for a clear view of the sky. The technical term for this is antenna masking. See, DGNSS relies on these incredibly weak radio signals that travel in a straight line from satellites in space. So if anything, a mast, a crane, even another antenna gets in the way, that signal can get weaker or be lost completely.
And this diagram here shows the theory behind it just perfectly. A DGNS receiver needs to see a bunch of satellites at once to figure out its exact position. But look here, even a pretty small mass structure can create this massive blind spot in the sky. It cuts the number of visible satellites from 7 down to just 4, and that severely compromises the whole system.
Okay, so that's the theory. This slide, this is the harsh reality. These are real-world examples of terrible antenna placement on drill rigs. You don't need to be an engineer to see that these antennas have almost zero clear view of the sky. This is just asking for failure.
But it's not always the super obvious cases. I mean, look at this installation. It seems pretty good, right? It's high up, it's mostly clear, but see those narrow poles? They created a small mast area. And the result? At certain times of day, when the satellites were in just the right or wrong spot and the ship was pointing a certain direction, boom. Crucial signals were blocked, causing huge positioning errors.
All right, so we've talked about physical blockages, the things you can see. But what about the threats you can't see? The next challenge is trying to navigate through a sea of invisible radio chaos.
First up is this phenomenon called multipath. Think of it like a signal's echo. It's when the antenna gets the clean, direct signal from a satellite, but it also gets a delayed echo of that same signal that is bounced off a nearby surface. This completely confuses the receiver because the whole system relies on super precise timing to calculate distance.
And these diagrams show you exactly how it works. A signal can bounce off a flat deck or a big vertical steel wall. That reflected path is longer, right? So the signal arrives a tiny fraction of a second late, and that introduces errors and instability into the final position. It's like phantom data.
The second invisible enemy is radio frequency interference, or RF interference. Here's the thing. The signals coming from positioning satellites are unbelievably weak by the time they reach Earth. That makes them really easy to drown out.
This diagram does such a great job of visualizing these invisible threats. A big vessel is just packed with powerful transmitters, and every single one creates its own danger zone around it. If your DGNS antenna happens to be inside one of those zones, that weak little signal it's trying to catch can get completely jammed. And the culprits? They're everywhere on a ship. We're talking about those big satellite communication domes, the spinning radar scanners, VHF radios. Heck, even a faulty piece of equipment nearby can blast out enough noise to disrupt the entire system. So, with all these threats, the physical stuff, the invisible stuff, how in the world do you make sure you get a perfect installation? Well, thankfully, there is an expert playbook for this, laid out by groups like the International Marine Contractors Association.
And it really all boils down to a three-step process. First, meticulous planning. You survey the vessel. You identify every potential risk before anyone even picks up a tool. Second, a flawless installation, focusing on perfect antenna placement and using top-quality components. And finally, ongoing maintenance, because even the best install will wear down over time in that harsh marine environment.
And let's talk about a detail that gets overlooked all the time: the cabling. Using the right kind of low-loss cable, avoiding sharp bends, keeping the number of connections to an absolute minimum, and waterproofing everything, that's completely non-negotiable. Every single connection adds another point of potential failure and signal loss.
So what's the big takeaway here? The crucial point is this. It doesn't matter if you're building a spaceship or just installing a marine GPS. Success in any complex system isn't about some secret trick. It's about rigorously, relentlessly mastering the fundamentals.
Which leaves us with a final question to think about. From the Wi-Fi in our homes to global financial networks, our entire world is built on invisible signals and complex systems. So, what small, fundamental details in your own world might you be overlooking?